they address that by supposedly listing all the ones that are allowed, or?
I don't recall. One way would have been to drop star.google. The other way would be to have either had Gmail filter attachments or have Gmail host a Swift on a domain that's not google.com. In general, the best practice is whenever you allow end users to upload content, you host on a completely separate subdomain. Not everybody always follows that within their organization. But one of the things to keep in mind, though, with cross-domain permissions in JavaScript is if you have cross-domain permissions set up within JavaScript, you don't necessarily have to upload something to execute within that security context, right? If I need a Swift to execute in your domain, I have to find a way to physically get the Swift onto your domain. But with JavaScript, if I can find cross-site scripting, then I can get my malicious code to execute in your domain without having to upload anything, right? I just send the malicious string and the get URL, and that gets reflected back in the page. And anything I send as JavaScript that gets reflected back into the page is going to be executing in the context of the page I'm cross-site scripting in. So in that scenario, it may actually be easier to take advantage of cross-domain permissions if you have cross-site scripting on your site, because all you have to do would be to inject an XHR into the page, and then you can leverage the permissions that are on other domains, or leverage cross-domain permissions. So if you're going to use the JavaScript cross-domain permission set models, you obviously want to check for cross-site scripting on your site, because any place where there's cross-site scripting, it may be able to take advantage of the permissions that are established for XHR requests. And in general, you would also want to couple the techniques with things such as content security policies. Last night, Brandon talked about content security policies and the way that they can be used to reduce cross-site scripting. I would recommend that if you're going to set up an environment where you're going to be using cross-domain XHR requests, you couple that with the content security policies to help reduce cross-site scripting, to ensure that a cross-site scripting attack against your page doesn't also give access across domain to other people's domains. You can whether you check the authorization for cookies, that's up to you. But like I said, some models do send cookies, some models don't. If you're combining a couple of different technologies, then you'd have to assume that cookies aren't going to be sent, because in some models they're not going to be sent. So you won't have the ability to make that decision. I think with content security policies, they chose to send the cookies along because they were expecting a CGI to receive that request, and the CGI could not only determine whether that remote domain was allowed to access information across domain, but you could also look at the cookies to find if that particular user on that particular domain is allowed to gain access to the cookies, or gain access to the response. And then the other thing that can happen here is ideas of transitive trust. If A trusts B and B trusts C, then can A access C? Would somebody be able to string these things together and be able to perform a worm? And the answer to that question is yes, and it's actually already been done. There's a site in China called RenRen, and it was basically a social networking site, think Facebook, but for Chinese students. And the way the worm worked was it first took advantage of an allow script access always permission on the page. So like a lot of social networking sites, it allows you to link to different videos to share with your friends. So on Facebook, you can link to a YouTube video to share with your friends. In this scenario, they were doing the same thing, but when they generated the HTML for the page, they said allow script access to always, which meant that that video on the remote site could execute script commands into the hosting web page. It was allowed to jump across domains to get into the parent HTML page. And once it was on it had JavaScript access into the parent HTML page, the attackers needed information in order to propagate the worm. I needed to know who your friends were. I needed to know what the tokens that were necessary to create messages. And all of that was on separate subdomains. So in order to get access to all the separate subdomains where the APIs exist to allow you to get access to the friends list, they looked around RenRen's site and they found out that RenRen was doing cross-domain sharing using the window.domain trick, where you set window.domain to the super domain. And that tied all of RenRen.com into basically one large superdomain. So once they had access into the hosting HTML page, they could then make cross-domain requests to friends.renren.com and data.renren.com to get the information that you needed in order to propagate the request and do posts into all of your friends lists. So that, essentially, once they had a foothold in one domain, they were able to chain the star.renren.com permissions together. So this is something that you sort of need to keep track of within your domain, especially if you trust other parties. So whenever I talk to people about cross-domain permissions, people ask me, are they evil, are they not? Some people believe that data should never leave the origin upon which it's hosted, either because developers will make mistakes as soon as you give them choices, or the end user isn't involved in the sharing of information between these two domains. It's actually done all at the code level, so the user doesn't know that information is being shared. But in some cases, the way I look at it is I tend to think that they're actually good. Because if you give them a formalized method, you can audit to the formalized method. You can train the developer for the formalized method. It's easier to audit for because you know what to look for. You're not looking to see if they're trying to read fragment identifiers across domains. You can look for set-specific things like a cross-domain XML file. And as long as they have an option to do it the right way, then you can transition them off of the ways, the older ways that were just sort of workarounds for the issues where they had to use eval on AJAX calls and JSON calls. Overall, I'd say the controls they're good, but the problem is there's going to have to be a lot of education around them before you start allowing developers to use them. You need to keep track of who you're sharing information with across domains. If you're using XHR or the JavaScript methods, you need to be extra sure that you audit those pages for cross-site scripting attacks, because if I can get a cross-site scripting attack into that domain, then I'd be able to take advantage of the cross-domain permissions that page had. You'd also want to take advantage of things like content security policies, which are coming up, as Brandon said, in Firefox 4. At least in my opinion, I think they can be used safely as long as you couple them with proper education and the top 10 best practices. If you're looking for technical references for any of these things, these slides will be available online on the OWASP site or the video. But in the slide deck, I provide links to all the different technologies. And then the one link at the very bottom was a talk given by Mehmet Akin from IBM, and he talks about secure cross-domain issues when building mashups. And if you didn't know what I was referring to with regards to some of the workaround techniques that I talked about with fragment identifiers and stuff, and using multiple iframes and some of the workaround tricks that people have been using, it's a very detailed deck which actually goes in and talks about the different methods that people have been using in the past. It's from 2008.